Hello everybody. In this video, I will show you the prototype I made within the context of my thesis, called GPU usage in real-time game audio tasks. The project was made using version 6.3 and the Universal Random Pipeline. It also implements fmod for audio implementation. This project uses GPU ray tracing to process obstruction and occlusion on different sounds. It uses the Unified Ray Tracing API, which means that it can run on basically any GPU, even those that doesn't have ray tracing cores. So when you play the sample scene, you can directly hear a sound on your right. If you go there, you will hear that the sound adapts to whether or not it's getting slightly covered. You can hear the differences. As the door slightly opens or closes, you can hear the sound muffling differently. Being on the right or on the left has a slightly different effect. With that sound, pressing the keypad will remove walls. Each wall has a different impact on the final result. Finally, you can hear the fountain noise getting slightly altered when trees are on the way. Inside the assets folder of the project, there is a csc.rsp file. Inside it, there is a define. To enable it, you can remove the hashtag. Also, in the sound tracing URT shader that can be found inside code, shaders, ray tracing, resources. You can add a hashtag define sound tracing debug and save. Once it finishes compiling, you will be able to see the rays inside the scene view. Each audio source has its own variables to interact with the ray tracing results. The first one, occlusion low pass frequency linear, modifies the data that is sent to fmod. Then, the low influence multiplier modifies how the darker rays affect the global effects. A smaller value means that the direct line of sight will have the most influence. Finally, we have the absorption cone angle. This variable increases or decreases the area covered by rays. To modify the scalability settings, you can go to the sound tracing game object inside the sound tracing context component. The first variable is the ray tracing build flags. It helps defining what you need when building the acceleration structure. Then you have the frame skips. A lower frame skips value will make the system run more oftenly, while a higher value will reduce the amount of resources taken, but will also reduce the accuracy. Then, the subslicing parameter in the rays per slice modifies the amount of rays that are launched per emitter. The subslicing parameter modifies the amount of slices that are in between the emitter and the listener. A value of 0 will only have one slice, that is, right at the middle. Each time you increment that variable, it doubles the amount of slicing. So 1 will make 3 slices, 2 will make 7 slices, etc. The range per slice is more straightforward. Finally, the distance for cone angles variable modifies the distance needed to start increasing the cone angle. You can also modify the effect on each audio event separately inside Fmod. Also, I personally only used a simple low-pass filter to process the acoustics. But I'm pretty sure that you can go further than I did and get even more creative. That's it for this video. I'd love hearing your feedback in the comments. Cheers!